So the next part that I want to explain is about bioremediation. Now bioremediation is actually a big area of study that encompasses part of it phytoremediation. Bioremediation means using anything living to reduce the impact of contamination. Now, in this case, in the soil. Now, most of the time, bioremediation is being coined together with the contamination of organic pollutants. But for metal-based contamination, okay, which the contaminants is from metals, it's more closely associated with phytoremediation, which is why only at this point we're talking about it. Now that is because when we have microbes, okay, now these microbes, they are invisible. Of course, they were going to absorb heavy metals, but here's the problem. This microbe, once you release into the soil, they stay in the soil. You cannot tell the microbes that, okay, once you have finished your once you have removed the heavy metals, then come back up. No, you cannot. There's, well, currently no way you can collect the microbes after you release into the environment, which is why using microbes to remediate heavy metals nowadays is not really a good idea. But if you have plants, now plants is different. Because why? Plants, they extend their root into the soil. Okay, that's number one. Now, even if they don't come up to the surface, you still can trace its root and then remove the root accordingly. Because why? Once you have the roots inside the soil, they will absorb, they will accumulate and remove the heavy metals from the soil. So in essence, if you can remove the plants, therefore you can actually remove the contaminants now. So which is why phytoremediation is usually closely associated with metal contamination in the soil because of its capability. Now, you can say that phytoremediation is considered an effective method because all you need to do is ensure your plants stay living for a long period of time, and it will slowly absorb and remove the pollutants from the soil. Now, when I say slowly, I need to explain a bit how slow a tree can remove a pollutant. It is said that a hyperaccumulator, even though a hyperaccumulator can absorb pollutants excessively more than any ordinary plants, it is said that hyperaccumulators also still need as long as 20 years, 20 to 30 years to completely remediate a contaminated soil. So how many years can you stay and see a remediation? The answer is not too long lah, which is why also phytoremediation people might consider. Now, if you're in a hurry to get that site cleaned up, phytoremediation probably is not a good idea lah. Okay, in other words, if you want things fast and you want to remove the contamination, I think soil washing is probably a better idea rather than phytoremediation. But here is the norm lah. If you look at Malaysia, phytoremediation usually, I think I'll need to explain first lah, not to over explain and jump the slide. So as you can see right there, phytoremediation means it's a removal of pollutants by using plants. And this is how it's done. So the root absorb the dissolved phase and accumulate into the upper part. So usually we'll prefer the contaminants to move up rather than stay in the root, but it's still fine because if you can remove the root, you're still doing the job. But most of the time they want the plants to actually absorb and lift the pollutants above the soil. Because what? Once they lift above the soil, they can just trim the plants away. So by trimming the plants, they are essentially removing the pollutants and keep going lah. Keep the phytoremediation going. So where were I just now? I was talking about the remediation option between soil washing and phytoremediation, right? Just now. Now, if you have soil washing, that will give you a fast result. Phytoremediation is just working too slowly. but it's still effective. So if you look at Malaysian context, most of the landfill, I'm sure you know, landfill accumulates a lot of pollutants, including organic pollutants as well. But in terms of inorganic pollutants, they are there, like the inorganic pollutants can be arsenic, aluminium, and so on. Heavy metals, you can say it. So landfills, once it is decommissioned, it will be closed and plant a lot of hyperaccumulators on top. So one of the best options for phytoremediation of a landfill nowadays is sunflower. If you look at sunflower, you feel like back to nature, isn't it? Essentially, it is not. Now, a lot of countries, especially in the Western countries, they use a lot of sunflower on their landfill because sunflower is a hyper accumulator for quite a variety of heavy metals and also organic pollutant. It looks very jolly. I mean, sunflower, whatnot, isn't it? Very big, yellowish. You feel happy, look at sunflower. But don't eat the sunflower seed because there's a report that sunflower seed contains a lot of heavy metal. And there has been some report also concerns that says that sunflower oil, the cooking oil that you can buy from supermarket, may have been contaminated. It has been reported, but I think our food, our sunflower oil you can buy from supermarket is quite safe enough. So that is phytoremediation. There are more. In fact, cannot cover all the plants that you have. Now, another example of your potential plants that can be used as a phytoremediating agent or hyperaccumulator, most of them comes from the herbal plant, like your pegaga. Pegaga, I'm sure you know, you eat as ulam, isn't it? Now, pegaga is said to accumulate mercury. Okay, so that's one. And some more that I cannot remember. Okay, there's one plant that I use a lot in my research, which is spinach. You eat a lot of spinach, but do you know that spinach is a hyper accumulator for cadmium? That is an issue, kan? So, but if the spinach is planted on uncontaminated soil, then it should not be a problem. Okay, I think enough said on phytoremediation. I will move on to the next part, which is agricultural waste in soil. So in this case, agricultural waste, it depends on what kind of things that you planted. Now, in Malaysia, I'm sure you know, palm oil is our major crop, and that is also a major issue in terms of waste disposal because oil palm plantation, they produce a lot of waste. Number one, it comes from the leaves. Okay, if not from the leaves, the fruit. After the fruit has been pressed and removed the oil, they have all those residual biomass. So the what we call empty fruit bunch and so on. I'm not sure if there's that. They have a lot. So what does that mean? That means it needs a bit of management. But in Malaysia, we have an innovative way on how to manage this one. Now, we know that these agricultural waste, they are organic and they are biodegradable, but instead of like putting in landfill, we make use of it. Let's see what we do. Okay, some of the waste will be left in the crop for natural decay, particularly regain lost nutrient, improve humus content in the soil. I have one word for the second point. It is used as mulch. If you still remember soil erosion, mulch is so important to reduce impact of rainwater. Yes, that is one. Okay, so which part of the oil palm is being used is the leaves, or in other words, we call it oil palm frond, Frond. So that is the leaves lah. Once they chop down, they just put it back into the tracks to cover those exposed soil. So there you go, mulching. Okay, number two, burning of the waste is not healthy practice to cause release of carbon dioxide and should be left decomposed and kept some carbon compound in the soil as humus. Now, the third point is probably applicable before this, maybe 10 years back, because 10 years before this, the combustion technology is not that good. So this has been a practice lah. Now, do you know that the waste coming from oil palm has been used as source of fuel? Yeah, people burn the palm kernel shell. It's actually the shell from the food, from the seed. They break it, they dry it. Now that seed shell contains a lot of oil. So of course they can burn. And previously people burn it to generate heat for boilers. but you can imagine the smell. The smell is so terrible. The smell, I tell you, is so bad that 10 years ago when I was driving back from Shah Alam back to Sungai Buloh, there's a factory there which has been closed. Yeah, they were closed because they were burning this thing and they got complaints. So government closed it lah. But nowadays, technology has been advanced. In fact, I think Malaysia also have built a few incinerators that specifically use municipal solid waste, and this waste from oil palm industry also may be a feedstock. Feedstock is a material that you put in incinerator. Incineration that burns it. So once they burn, they will generate heat. So this is one way energy can be generated, not by burning fossil fuel like coal, but can be, this agricultural waste can be a feedstock to replace coal. At least burning this is cleaner than coal. So I disagree with this point, because I think this point probably is like 10 years ago. But nowadays, people have used palm kernel shell to generate electricity. And those countries are EU, European Union. So this is true story. European Union import palm kernel shell from Malaysia to generate electricity. They no longer burn coal. Okay, now last point. Some waste like oil palm meal effluent can cause disaster due to high volume release to water bodies. Okay, for those who don't know what is oil palm meal effluent, it's actually the wastewater coming from sanitization of the oil palm fruit. So they use steam. Steam essentially is water, but in gas phase. So they sanitize all those palm fruit, so it will generate liquid. So these are liquid lah. Now this liquid, they are acidic and they're oily. So what do people do? They will collect it. They will collect oil palm meal effluent, and they will just leave it to dry. So once dry, they have all those sludge, which is acidic and oily. Again, very smelly as well. So what do people do? So this is what people do. I think I jump a little bit by telling you what people do with the biomass. So we have solid biomass and also liquid biomass. And you can see from this the biomass where you can do, but I can tell you the majority of biomass in Malaysia comes from oil palm industry. Part of it also comes from domestic waste like your local government. These are probably the wood trimmings, and also let's not forget Malaysian soil, Malaysian waste. This is half of it food waste. Yeah, food waste is also right here, although it's not being listed. So okay, now majority of the discussion that we're going to go through is regarding to the waste from oil palm industry. So empty fruit bunch is the tandan we call it, the tandan of the oil palm fruit. It's fibrous and it can generate electricity, but one problem. Now, for those who don't know what is empty fruit bunch, it's actually like a cluster that has been removed of the oil palm fruit. The fruit has been removed, so what's left is the cluster. Now, this cluster is organic, but the problem is this cluster also traps a lot of moisture. So this is a problem. Like empty fruit bunch, although it can be said to be able to be used as a source of combustion, but they're too wet. So that's why empty fruit bunch also is a problem. Palm oil meal effluent, I said to you earlier, is a liquid. It usually being left to dry, but there's something else people might do. Mesocarp fiber is the fiber, the hampas you call it. So every time we want to extract palm oil from the fruit, it is pressed. It is physically pressed. So the juice, when they come up, they carry some oil. And then what's left after pressing is solid organic matter, and that is fibrous. We call it mesocarp fiber. Now, this one also may have a bit of issue in terms of moisture, but at least the moisture is not that bad because why? The fruit is already compressed. So in other words, any liquid that is already in the fruit, already being removed, that includes moisture. So mesocarp fiber is not that bad in terms of the moisture content. So yeah, it has been used as a feedstock in the incinerator to generate electricity. Similarly with palm kernel shell as well. Now palm kernel shell, it's said to be like 70 to 90% carbon. So it has high carbon, it has high oil content. So palm kernel shell is like a very good source of fuel. Like I said to you just now, it has been used to replace coal for generation of electricity. Now, there's one thing that I did not cover just now, palm kernel cake. The palm kernel cake is the sludge. Remember just now, this one, for me? Palm oil meal effluent, after they dry, they will leave a semi-solid, a sludge, we call this one. So that sludge is called palm kernel cake, a residue. It is very wet, it has high content of organic matter, and it's also acidic. So you must be wondering, what are we going to do that? Because this is the thing that I did not cover. So, okay, let us go to the next slide. Okay, so this is the so-called value. I mean, not value, the how much of this waste is being produced. So let's have a glance. Number one, empty fruit bunch. Nothing much we can do. It's wet. And I would say this one usually goes to landfill. Not that we cannot do anything, but the problem is it has a problem. It is too wet to be used as a combustion or whatever. So people rather throw it away. Now, if it's not thrown away, then most likely it has been chopped down into small pieces and used as a mulch. I don't think this one goes to landfill. Probably is used as a mulch. Palm kernel shell, 8 million tons. And for your information, these 8 million tons, it's quite safe to say that all 8 million has been exported. If it's not because of the EU embargo on oil palm products, I think all 8 million has been exported. Now, not only palm kernel shell is exported to EU, it is also exported to countries like South Korea, Japan, and China, because these three nations also have their own specialized incinerator that burns palm kernel shell and generate electricity. Mesocarp fiber is used primarily in Malaysia. I think this one cannot be exported, only palm kernel shell. And then homing, as I said to you earlier. Now, what do we do with this agricultural waste? Like I told you just now, thermal conversion, you burn. If you can burn it, you burn it. Once it's burned, then it will generate electricity. Okay. However, there are certain part of these so-called organic contaminants. They are too wet to be burned. Like for example, the sludge that I told you, palmy sludge. So they are wet, but they have high organic matter. What you need to do is take it, put bacteria, and if this bacteria is put in a very anaerobic condition, that means no oxygen, it will go to conduct anaerobic respiration, and guess what? It generates methane gas. Yes, it's called anaerobic digestion. So this process, this methane generation uses the sludge from POME, and the process that converts the sludge to generate methane gas is called anaerobic digestion. It's a very famous word. It used a lot, and you will see a lot once you're working outside. Okay, now in other words, this anaerobic digestion is also considered bioremediation because it uses microbe. Yeah. Now another type of bioremediation of this so-called material, they are using pomade. Now, but this pomade, like I told you just now, is very, very wet. It's a liquid. In fact, it contains a lot of acid. Now, why they are so acidic? Because they contain a lot of fatty acid. Fatty acid, they all contain carboxylic acid, like acetic acid, propionic acid. Now, they can be either isolated by filtration. So this pomade, this so-called wastewater pomade, acidic, they may be channeled into a filter where they can filter and isolate all those organic matter, and they may have some further biological conversion in which the bigger fatty acids can be broken down and oxidized to form this smaller acetic acid, smaller carboxylic acid. Acetic acid most likely is used as a feedstock of plastic, and I think it could be also used as solvent. But propionic acid and butyric acid, they are used to manufacture polyester. So these are the feedstock that can be used to make plastic. Okay, so there you go. Bioplastic from the isolated carboxylic acid from palming, and they can be have like further reaction, further processing to manufacture polyester, the plastics, and then the other words, as usual, any organic compound can be composted. So that's probably the other major use lah. Apart from generating electricity, uh, organic waste or the organic waste from agriculture sector, they are used to make compost lah. This is you can say it's a soil conditioner as well as fertilizer into use. So there you go. This is the flow chart that shows you how organic waste from the palm oil industry has been recycled.